Welcome back. This is an Aleks training video on calculating a molar heat of reaction from formation enthalpies. Okay, I've got already written down the long or part of the long form of this to actually understand this, where this is coming from. And then on the right, I'm going to give you the shortcut, the short form, what I would do if I had to do this problem. I would not go and reinvent the wheel to do it, but doing it once makes some sense to you why you're doing it, rather than just do this, then do this, do this. It's not just a recipe. There's an understanding behind it. So first of all, on your Aleks program, you've got a data, like a button on the right that says data, and you can look up all kinds of information, melting points and all the information about different elements and tons of stuff. One of the things that you can look up are the standard formation enthalpies for every single material that you're going to be using in the program. So they've given you a formula they've given you an equation that you've got some kind of this is a ethane gas burning and making carbon dioxide and water. So it's a combustion reaction with some kind of a ethane gas. Well, ethane is made with hydrogen and carbon. Okay, so these are our standard formations. We did this earlier, where you find out what is in this C2H6, what is its standard forms, and then making it to where it's just 1 mole. This has been determined in the lab. This is how much energy is, in this case, released when ethane gas is made. So it's an exothermic reaction with 84 kilojoules per mole. For every mole of this made, that's how much is released, energy is released. Now, this is not actually made because it's not a compound. This is just oxygen with oxygen, so there's no heat of formation. This is called heat of formation. Let me write that down. Heat of formation, or enthalpy of formation, H of F. This is how much heat is released or absorbed whenever whatever you're talking about is produced. Okay, so the heat of formation. You're going to use the heat of formation of each material in your stuff in order to find out what your enthalpy is for total. Like, if you're not given it and you have to figure it out, you actually have to go to a table for every single molecule that you've got and find out what the heat of formations of each of those were. Then you can add and subtract to find out what the heat of the entire reaction will be. What's the enthalpy of your reaction? Okay, so this one is 0 because it's just in the free state. Carbon dioxide gas. Here's how much heat is released when you make carbon dioxide. Liquid water, and you have to be careful because in your table there's liquid, there's solid, there's gas. You have to pick the one that you want. For liquid water to make, it's going to release 285.8 kilojoules per mole. Okay. Now the long form, what you would actually do if you had to do this, from scratch, is you say, okay, well, here's one reaction of making this. Here's this reaction of making this. Here's this reaction of making this. So what I'm going to do is say, okay, well, this is not a product, it's a reactant, so I want to go backwards. So this must be positive 84.5 joules on this side, but then that's only 1 mole. I need to double it. So I take positive 84 joules and I double it and then find out how much this is. Then this is 0 because it doesn't, it's always 0. When you multiply, it's still 0. So this is going to be doubled 84 positive. This is a product, so it's going to be negative 393, but I have to multiply it by 4, find out what that is. And then this is negative 286, multiply that by 6, find out what that is. Then when you do the final, so you're essentially acting like each one of these reactions is a sequence, and you use Hess's law to find out whatever this is added to whatever this is added to whatever this is gives you the total. Okay. I know that didn't help you because I didn't want to spend the 30 minutes it would take me to do this problem. But I'll show you the easy way. Okay. You're going to take the enthalpy of the products and you're going to subtract the enthalpy of the reactants. This is delta H of the reactants. All right. So your products, you're going to take whatever carbon dioxide is, the negative 393.5, multiply it by 4. So that's on this side. So you're doing the products first. So it's going to be 4 times whatever is in the table. And the carbon dioxide was negative 393.5. Okay. You're going to add to that 6 times whatever water was. So 6 times negative 285.8. Okay. Now you're going to subtract, because we're going to do the reactants next. Okay. So I come over here, there's 2. Okay. So 2 times, find out what the ethane is, negative 84, plus 7 times whatever the oxygen is, in this case it's 0. Right. Move that to where you can see. Okay. Now just do the little math inside it. Okay. 4 times negative 398 is negative 1574. 6 times negative 285.8 is negative 1714.8. Negative times 84 is negative 168. And that's 0. So negative and negative is going to add 168 here. And then 1574 plus 1714 is negative 3288.8. Add these together. Negative 3288.8 plus 168 gives you negative 3120.8. And then they ask you to find it to the nearest kilojoule. So I'm going to have to round that up to 3121 kilojoules. Okay. So what they're saying is how much energy was released or absorbed when you take ethane and burn it in air. Okay. Well, ethane has tons of energy. Water has less energy, so when it turns into this stuff, you're going to lose energy. That's why you burn it. You're burning it for energy, right? That's the energy company sells you that gas, and so that means that it's going away. You're burning it, it's going away, and this is how much energy, and it's a lot. That's a huge amount. That's why you would burn this stuff for fuel, because it gives you tons of heat for the amount of molecules that you have. All right. So this is the molar heat of reaction. Okay. Now this is the heat of formation of each one, and then this is the heat of reaction. This is how much, what we usually see when we see delta H equals, in this case, negative 3121 kilojoules. Okay, that's the heat of reaction. All right. So I would do it this way. I didn't even do it this way. This is hard. You're using Hess's rule. Here you're just essentially looking up the things in a table and then making sure you multiply them, and then it's products minus reactants.